In this video, I want to talk about singularities and how our idea of a singularity, such as one within a black hole, misleads us and actually keeps us from understanding the fourth dimension and how there's this fourth spatial direction leading into what we think of as the very small. So, if we imagine our universe as a 2D field or sheet, and we think of a black hole within that sheet of space, when we look at the math that says if you're allowed to keep going inward, we look at it as the mass breaking down. But the math isn't talking about a mass breaking down, it's just talking about continuing inward. We say that it reaches a point of infinite density, a point of infinite density, but this is not what the math is saying. The math is not saying that there's a point. So if we go to my own graphic from my book, we can see that this is pretty much the same picture. But what I'm doing is I'm showing how when we get to the point of very small, say we're going in a linear direction within our field of space, when we reach the point of very small, the quantum level, it goes inward into this fourth dimensional direction. But certainly when we reach the point of infinity, or rather when we reach the point of infinity, it just means something is continuing inward without end, or continuing in this fourth direction, this fourth spatial dimension. So the problem here is that we are creating an artificial point that's not actually in the math, but because we look at it as small, we say that this infinity has to be a point. It is not. There's actually no point there, and it's not small, it's in a direction of infinity. So really quick, or maybe not so quick, if we're thinking of space as a flat field without any outside to it, the fourth dimension could be described as the outside, then we look at mass breaking down and we say it has to reach a point of infinite density. But see, we don't have anywhere to go with that because we're looking at it from a flat perspective. And yes, a three-dimensional perspective in this regard is a flat perspective because we're not seeing the fourth dimension, which is what we think of as the direction of very small. So we just see that it gets smaller and smaller and smaller. So we go, at some point, it reaches a point of infinite density, a point, because we don't have a direction to go in. But when we, and we'll pull up a new layer here, when we look at it as a field, so this is the same picture that we just looked at, getting smaller and smaller and smaller, and then breaking down to where it reaches infinity. We don't have to say this is a point, because when we understand that the direction of small is an actual fourth dimension, we can see that it goes into this fourth direction, and that this can be infinite because it's a fundamentally different direction. We no longer have to look at it as a point of infinite density because we see that it moves in a fourth, fundamentally different fourth direction, which is the fourth dimension, which is the realms of what we think of as the very small. But when we get to this point of smallness, of size, we are not getting smaller anymore. We're moving in another direction, and it's getting more and more distant as we move in this direction to potentially infinity. There's no end to this direction of small. No end. No end to the direction of small because it's a fundamentally different fourth dimensional direction.